Now the question is, a circle passes through 3 points A, B and C with the line segment AC as its diameter. A line passing through A intersects the chord BC at point D inside the circle. If angle DAB and CAB are alpha and beta and the distance between the point A and midpoint of line segment DC is D, prove that area of the circle is given expression. So we have this circle and AC is one of the diameters. So we have this diameter AC, and then we have a point B, and we construct this triangle ABC. This triangle ABC with this angle B is 90 degrees. And this is your center, say O. And we join B with O. Now through this point A line is drawn which intersects BC at this point D. And says angle DAB and CAB are alpha and beta. So angle DAB is alpha and this whole angle it is beta. And it says distance of A with midpoint of line segment CD, it is D. So if we take this midpoint as M, so this is equal to this, then this distance is given as D. Basically we have to find radius of this circle. Now what we'll say is, this is origin and radius is suppose R, then this is R comma 0 and A is minus R comma 0. Now this angle is beta, then angle at the center will be this 2 beta. So coordinate of this point B will be R cos 2 beta and R sin 2 beta. Now what we'll do is we'll first write equation of BC, and for that we'll find slope of this line. Now slope of BC will be y2 minus y1, and which is R sin 2 beta upon x2 minus x1. So there will be this R cos 2 beta minus 1. Now this R and R will cancel. This is 2 sin beta cos beta, and here will be this minus 2 sin square beta. Now this 2 sin beta will cancel. So this is minus cot beta. And we have this point. So once we have point and slope, we can write equation of BC. So equation of BC will be given by y minus 0 equals minus cot B x minus R, or simply we can write this as x plus y tan beta, and it is equal to R, and that's our first equation. Now we'll find equation of AD. Now this angle DAC, it is beta minus alpha. So slope of this line AD will be simply 10 beta minus alpha, and once we have this point and slope, we can write the equation. So equation of AD, it will be y minus 0 10 beta minus alpha and x plus R. This is y equals 10 beta minus alpha into x plus R, and that's our second equation. Now we'll solve these two equations to find this point D. So what we'll do is we'll put the value of y here. Now y is minus cot beta x minus R, and it will be equal to 10 beta minus alpha into x plus R. Now we'll take x together and R together. So we'll get x as 10 beta minus alpha plus cot beta, and will be this R cot beta minus 10 beta minus alpha. Now we'll change everything in sine and cos. So it'll be this x, and then this is sine beta minus alpha, sine beta, cos beta minus alpha, cos beta, whole divided by cos beta minus alpha, sine beta, and here will be this r, cos beta minus alpha, minus sine beta minus alpha, divided by sine beta cos beta minus alpha. Now cos beta minus alpha, sine beta will cancel. Now this is cos A cos B plus sine A sine B. It is cos A minus B. So it will be simply cos beta minus alpha. And this is cos A cos B minus sine A sine B. So there will be cos A plus B. So we can write this is cos beta plus beta minus alpha. Now this is x cos alpha, and this is r cos 2 beta minus alpha. So x coordinate of D, it will be r cos 2 beta minus alpha upon cos alpha. And now we can find y, and we know that y is 10 beta minus alpha into x plus r. So there will be 10 beta minus alpha. X is this value plus r. So we'll take this r common, and then we'll have cos 2 beta minus alpha upon cos alpha plus 1, which is r10 beta minus alpha, and this is cos 2 beta minus alpha plus cos alpha upon cos alpha. Now this is cos C plus cos D, and if you put the formula for cos C plus cos D, we'll write r10 beta minus alpha. Now this is cos C plus cos D, which is 2 cos C plus D by 2. So it will be this 2 cos C plus D. Alpha will cancel, so it will be this cos beta, and then cos C minus D by 2. And then it will be this cos beta minus alpha upon cos alpha. Now 10 is basically sine upon cos, so this cos part will cancel. So we'll get this y coordinate as 2r sine beta minus alpha cos beta upon cos alpha. So once we have x and y, we can write coordinate of this point B, and coordinate of this point D will be given by r cos 2 beta minus alpha upon cos alpha, comma 2r sine beta minus alpha cos beta upon cos alpha. Now we already have coordinate of C, and C is r comma 0. So we'll find midpoint of CD, which is M. So coordinate of this point M will be this r cos 2 beta minus alpha plus cos alpha upon 2 cos alpha, and here it is 2r sine beta minus alpha cos beta upon cos alpha divided by 2. Now here this 2 and 2 will cancel. Now this is cos C plus cos D. We can write 2 cos C plus D by 2 into cos C minus D by 2. So it will be this M, and this is R, and this is 2 cos C plus D is beta, and C minus D is beta minus alpha upon cos alpha, and this is r sine beta minus alpha cos beta upon cos alpha, and we have this 2 here, so this 2 and 2 will cancel, so that is a coordinate of m. Now once we have m, we know that this distance am, it is given as d, so basically am square is equal to d square, so we can write am square, it is equal to d square, and am is distance between a and m, and a is minus r comma 0. So it will be this r square, and here we'll have cos beta minus alpha upon cos alpha plus 1 whole square and plus, and here we'll have sine beta minus alpha cos beta upon cos alpha whole square. Now we simplify this, we can write r square, and here will be this cos square beta upon cos square alpha. Now this is cos square beta minus alpha, and this is sine square beta minus alpha, and then plus 1 plus 2 cos beta minus alpha upon cos alpha. So basically we can write this r square as d square cos square alpha upon cos square beta plus cos square alpha plus 2 cos alpha cos beta and cos beta minus alpha. So we have got this r square in terms of d, alpha and beta, and we need area of this circle. So area of this circle is pi r square. So all we need to do is we have to multiply it with pi. So area of the circle is pi d square cos square alpha upon cos square beta plus cos square alpha plus 2 cos alpha cos beta and cos beta minus alpha, and this is what we need to prove in this question.